But yeah, so the next topic I want to get into is kind of just for the people who aren't really computer savvy, who like, you know, see the computer and there's a lot of stuff that happens in the computer that we don't understand, I don't understand. But on a basic level, it's all about gates. That's who this guy is. But not Bill Gates, logic gates. So thanks for laughing. Sorry, I have a weird sense of humor. Anyway, gates and logic gates. Well, let me just back up. The whole idea of a computer is basically two philosophical and technological. It's the marriage of philosophy and technology. So there was a guy named George. I think his name was George, but his last name was definitely Boole. And he came up with this idea of Boolean logic. He was a mathematician, and his idea about Boolean logic was basically could be summarized in the idea of that every single human decision can be modeled as a series of true and false logical decisions. So you might think, that doesn't make sense, like where do you want to go eat? But where do you want to go eat can be, do you want to go eat here? No, yes. Do you want to go eat here? No, yes. You want to eat here? Yes. What do you want? Do you want this item from the menu? So that's how computers think. The mind of a computer works this way. The zeros and ones, 0 represents false and 1 represents true. And so Boolean logic is the first thing. And then at some point it was somebody from France, I don't remember his name, didn't have time to look it up, but he decided, hey, we can combine this idea of Boolean logic with electronic circuits, right? And so what I have there is a diagram of an AND gate, and it's kind of simple to understand. You know, if input A is plugged in and input B is plugged in, the little output light turns on. If input A or input B are both not plugged in, it's not on. If only input B is plugged in, it's not on. If only input A is plugged in, it's not on. So what a computer is, what the CPU is essentially a bunch of little logic gates, extremely small actually, extremely complex, extremely layered, and you can model out like mathematics with logic gates. So there's the arithmetic language unit, which goes along with the CPU, which does mathematical calculations. But essentially, like in thinking about computers, no matter how sophisticated the technology is, like, you know, whatever program you're using, the first computer in 1950 and the computers we're using today do the exact same thing. The materials have just gotten better, the performance faster, the software more complex, and there have been a lot of new high-level languages now coming, you know, like JavaScript and different things. But computers just, there's no magic. It's just a machine that says yes or no to a bunch of things in a row very fast. And that is how it works. So anyone who didn't know that, I'm sure, I can't remember a gentleman's name who does hardware. He probably already knows all this, but anyway. So, but it's important, the important takeaway is that no matter what language you're in, no matter how fancy what you're using is, you're still fundamentally translating what you're doing down to that very raw level of, you know, electricity, silicon, metal, right? So back to like close out this whole section, what is programming? Programming is not, so it's not the software you're using, it's not the language you're using, it's not how, you know, the servers you have. What it really is it's a way of thinking. It's a way of being able to see a problem and follow certain problem solving steps to execute that problem using a machine. And this is like a quote that they always say at Turing, but it's true. Like the code you write is worthless and your ability to program is priceless. So like look at a chef, you know. A chef is not, one meal that a chef makes is not that valuable. The food will spoil, you know what I mean? Eventually will get eaten and that meal will be gone. But the chef is valuable because the chef has that knowledge of how to make that food. How to take a set of ingredients that they may never have even seen before and make something delicious, right? And that's what a programmer kind of does. You take code, you take languages, you take information from servers, and you make it into something that's like a meal. It might work really well at the time, but in the future, something else is going to come out and that program will no longer work, or the program will serve its purpose and it won't be needed anymore. So as you're writing code, don't ever be afraid to just like delete your whole program and start over. Like as long as you can still have, you know, your use of your brain, you'll be able to rewrite anything you do. And that's important to programming too, is that detachment from your code and your more attachment to the idea of, okay, what do I need to do to solve this problem? Or how might I imagine this system working? And those type of thoughts are what really separate like the amazing developers from the great developers. You know, the people who can look at something and immediately know, you know, synthesize huge amounts of data. And that comes with practice. It doesn't take anything other than practice to get there. Like I'm at the same point you are. I just maybe have like 7, 8, 9 months of a head start, but in 7, 8, 9 months of what I did, guaranteed you'd be better than I am. Like it's a huge field, and web development is one component of it, but hopefully at least that gives you guys some sense of how I think of programming, and now we'll kind of like move more into the web aspect of that, or how do you take this programming stuff and make websites out of it.